In corporate boardrooms, strategy decisions hinge on complex numerical data. Executives often find themselves staring at dense, static spreadsheets, trying to map out a path forward based on fixed numbers. But strategy is fluid. As soon as the numbers are displayed, stakeholders start asking questions. They need to know what happens if cost parameters increase by 10%, or if timeline variables stretch out another 6 months. Because standard models are locked in static PDFs and spreadsheets, those questions stop the meeting cold. The presenter has to manually update the underlying formulas, re-export the entire document, and try to regain the room's attention. This split-screen comparison shows the operational alternative. On the left is a static table of numbers, locked in place. On the right is a dynamic web component generated directly beside a chat window, complete with interactive sliders that instantly adjust the bar chart below it. This functionality comes from Claude Artifacts. It allows you to render live, interactive web utilities entirely within the interface, bypassing the need to open external development environments or configure web hosting servers. Running this workflow requires 3 things: an active Claude account, clearly predefined mathematical formulas, and source data that is completely non-confidential. By converting static documents into interactive applications, analysts transition from passively reporting historical numbers to actively building real-time strategy tools. Implementing this requires a strict 5-step sequence. Step 1 begins with system configuration. Before generating any code, you must manually navigate into the platform settings and explicitly toggle the Artifacts feature on. This visual breaks down Step 2, preparing your structured data. Feeding raw numbers into a prompt will fail. The data must be explicitly separated into input variables, the mathematical formulas that connect them, and the specific visual elements you want to display. You need to know exactly what user interface elements you want to use before you type your first instruction. This step also requires strict data governance. Unencrypted, confidential corporate data must never be submitted to public AI models. Establishing precise mathematical logic and strict security boundaries prevents operational liabilities down the line. When professionals try to generate these tools, they often hit a wall in Step 3. They submit generic prompts and receive standard static text paragraphs in return. This prompt schematic highlights the exact fix. You must explicitly command the AI to generate a functional format, such as a React component or an interactive web widget. The prompt must list the exact user interface controls you need. If you want dynamic sliders, toggles, or specific types of charts, ask for them by name. Next, instruct the system to map those requested UI controls directly to the structured input variables you defined back in Step 2. Precise instructions in natural language are what bridge the gap between receiving a conversational summary and receiving a functional, interactive application. Moving to Step 4, the requested tool will render directly inside a side preview panel for immediate testing. Here is a live test scenario, an interactive dashboard for a New Zealand infrastructure funding proposal. We see the input controls at the top and the central bar chart mapping financial outcomes. You grab the construction delay slider and modify the variable. The interface instantly recalculates, showing exactly how the delay increases required ratepayer contributions on the central chart. Before presenting, non-developers must audit the math, verifying that the chart's visual output exactly matches the background formula logic to ensure soundness. If the math is slightly off or the color contrast is poor, you use natural language instructions in the chat to correct those specific rules until the preview is accurate. Step 5 is deployment. You simply publish the link or copy the generated component code to use it in your final boardroom meeting. Subjecting the tool to rigorous live testing and formula validation ensures the data is credible and your reputation remains intact. This specific workflow applies to almost any operational data stream. The sequence shows how the interface adapts. First, you can generate return on investment calculators equipped with input fields that recalculate financial yields instantly during client pitches. Next, you can upload CSV files and prompt for visual dashboards that allow users to filter metrics by specific regions or time periods. You can even build operational compliance forms that calculate risk scores based on user inputs and visually highlight the required follow-up actions. Eliminating manual formula updates and document re-exports directly accelerates the speed of executive decision-making. The next time you prepare a static model, try running those variables through this interactive protocol first.